Hey everybody, this is Mr. Enyart with Module 2 in Grade 6, and this is Lesson 7. Lesson 7, the relationship between visual fraction models and equations. Now, this can get pretty tricky, hard to visually understand in the way we've learned math most of our lives, but I'm going to do my best to help you understand the different types of models I can make and how they help me understand the math behind the problem. Because we all know by now that we're just going to take this mathematically and we're going to rewrite 3/4, but then instead of dividing 2/5, we're going to multiply by its, that's right, it's reciprocal. So when we multiply by a reciprocal, we switch the numerator and denominator, so it's just 5/2. And of course, that's going to give us 15/8, which is going to give us 1 7/8. So understanding the math kind of helps me better understand the models, which is why I'm starting with that. And I'm going to show you this partitive way first. And then I'm going to show you the other method as well so that you can kind of figure out what tool works for you, because we know that we can flip-flop things in certain operations as long as it fits the rules of the operations. So let's look at the partitive one. And this is where you have to understand that what you're missing is the biggest number. Because whenever I divide by a fraction, it's like multiplying by a whole number or by a mixed number, and therefore my number is going to get bigger. So when I look at, let's say, 12 divided by 3, I'm dividing a whole number here. So this number has to be smaller than what I started with. And when that's the case, I draw a tape diagram based on the biggest number in the problem, in this case 12. And then I'm going to break it into 3 pieces because my divisor is what I'm breaking it into. And then I can figure out that if this is equal to 12 and I'm breaking that into 3 pieces, that these have to be worth 4 apiece in order to make 12. But since over here I am not taking away a whole number, I'm taking away a fraction, what I need to do is draw my tape diagram based on what I don't know. Okay, I don't know yet how much I'm going to have, but I know that my biggest number is what's missing. And remember, 1 7/8 is much bigger than 3/4 or 2/5. But I am still breaking it up into 2/5. So what I'm going to do is break it into 5, because that's my divisor, so 5 equal pieces. And the 5 pieces represent fifths. And then I'm just going to either shade in or mentally make a point that I am breaking it into 2/5. And what is it I'm breaking into 2/5? I'm glad you asked. I'm breaking 3/4 into 2/5, which means that the 2/5 is coming from 3/4. So those 2/5 combined would equal my 3/4, and I can't divide 3/4 by 2, but what I can do is I can make it 6/8. Now 6 can be divided by 2, right? And that would be 3/8. So now that I'm done putting in that the 3/8 and the 3/8, which equals 6/8, which is the 3/4, that's the 2/5 that I had broken it into. I can then find my total, my missing number, right, by combining all the 3/8 5 times, which of course 3 times 5 is just 15. And they are all still the size of 8s. And 15/8 will transfer into 1 7/8 as I realize I can take 8/8 out of there, and that leaves me 7/8. So that's one method. That's the partitive method. So the measurement method, which honestly this one makes a lot more sense to me. This one took me quite a while to really break down and understand how the math works, how the numbers work. But now it's all clicking. But measurement really seemed to make sense to me a lot easier, because in my mind I'm trying to realize, hey, how do I figure out what is 2/5 in comparison to the size of 3/4? Because, with different piece sizes in 4ths and 5ths, it makes it hard. So my first instinct is to make them all equal size pieces and then compare by how many of them. Which, of course, if I do that, 3/4 and 2/5, both of those can become 20ths. Right? So 4 times 5 is 20 and 5 times 4 is 20. So if I make them 20ths, I basically am going to take my 3/4 and make them equal to 20ths. And since that's times 5, I do this times 5 and I get 15. And then 2/5 is going to be equal to 20ths as well, which is going to be times 4. So this is times 4, so it's 8 20ths. So now what I have is I have 15 20ths divided by 8/20. So if I have 15/20 of something, how many groups of 8/20 can I pull out of that? And that seems to make a lot more sense to me as I go to make my tape diagram. And so the reason I like the measurement method is because now that I have equal denominators, common denominators, I just, do it like I would think to divide up 15/20. I'm going to color in 15/20. And now that I have 15/20 shaded in, I can mark that, kind of up here if I want to, right? 15/20. I'm now going to find groups of 8/20. So I'm going to outline 8 of them. So that's a 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then I'm going to do that again. So here we go. 1, 2, 3, 4, 5, 6, 7, 8. And I noticed that I was able to do one full group, but this group is not full, is it? Over here, I've got this little leftover hangover. Now, to make a whole of these figures, I was able to make one group. This is supposed to be another group, but it's not a complete group. Well, how many pieces make up this group? That's right, 8 pieces make up the group. And how many of those pieces do I have? 7. So I actually have one whole group, and then I have 7/8 of another group, which obviously combined would be 1 and 7/8. So I prefer the measurement method myself, but you may like the partitive method, whatever works for you. So for the sake of it can be confusing, I want to give you one more example. If I had 3/5 and I divided it by 1/4, that means that I can be taking 3/5 and I can be multiplying it by its reciprocal, which is 4/1, which is going to give me 12/5. And again, I recognize right away this is an improper fraction, and I can take 2 wholes out of that, 2 sets of 5/5, and that leaves me 2/5. And I want to show that in a model, and I'm going to use both methods. I'll use the partitive method here, and then I will use the measurement method here. So in the partitive method, I'm going to make my tape diagram, and it could be thicker and easier. And I'm going to make it into fourths because that is what I am dividing here, right? And I know that I'm doing groups of 1/4. I don't know how many groups it's going to be. And so I break it into fourths, and then I'm going to make the bottom worth the unknown amount because I know it has to be bigger than what I have since I'm dividing by a fraction. And I'm going to color in 1/4 of that. And then I'm going to mark that that 1/4 is coming from the value of 3/5. So this made it pretty darn easy here because 3/5 in one piece means this piece is worth, that's right, 3/5. And since now that I've added all my 3/5 to all my boxes because they're all equal, I end up with 3, 6, 9, 12/5, which is exactly what I had up top. So it's equivalent to 12/5, which is going to relay into 2 and 2/5. So the partitive worked. Now let's try the measurement. So again, I recognize in this one that I cannot necessarily understand how big a fourth is compared to a fifth is. And so if I make them like denominators, it becomes a lot easier. And so the closest denominator I can get to both of those is 20. 5 times 4 is 20. And therefore, my equivalent fractions, since this is times 4, are going to be 12/20. And this is times 5, so it's going to be 5/20. And what I'm going to do now is I'm going to break this into 20ths. And so now that I have 20 equal pieces, again, my problem now translates as, after finding equivalent fractions, to 12/20 divided by 5/20, which means if I had 12/20, how many 5/20 can I make from that? So I start by coloring in 12/20, and you can count those, but there is 11 and 12. And then I'm going to mark out how many 5/20 I can make. And so I'll just count out 5. 1, 2, 3, 4, 5. There's 1. And then do that again. 1, 2, 3, 4, 5. And then I'm going to do that one more time. 1, 2, 3, 4, 5. And so I was able to make two whole groups right here. Here's one group of of the 5/20ths. Here's another group of the 5/20ths. 1, 2, 3, 4, 5. And then I've got two leftovers out of 1, 2, 3, 4, 5 pieces. So I have two wholes, groups, and then I have 2/5 of my next group. So look back through these, make sure they make sense to you. In the long run, you want to just keep it simple and make sure that you can find the correct answer, whether that's using the reciprocal and multiplying as we did mathematically, using the partitive method of a tape diagram, or the tape diagram method of measurement, and this one said measurement, but again, I want to show you both. Then I think you'll be just fine. All right? Enjoy.